The speed of human thought is roughly 10 to 20 words per second. But last week, the ceiling for artificial intelligence didn't just rise, it shattered. We are looking at 1,000 tokens per second. This is GPT-5.3 Codex Spark. It is not just another incremental update, it is a fundamental shift in how we interact with machines. The lag is gone, replaced by something that feels less like a tool and more like an extension of your own mind. To understand why this matters, you have to realize that for years, we have been limited by the hardware tax. Every time you ask an AI a question, there is a physical weight for electrons to move across a cluster of GPUs. But that just changed. For the last decade, NVIDIA has been the undisputed king of AI. Their H100 and B200 chips are engineering marvels, but they have a secret weakness. They are designed for throughput, doing many things at once, not necessarily doing one thing instantly. When you chain thousands of these chips together, the data has to travel across wires. That travel time creates a latency floor. No matter how many GPUs you add, you can't make a single response faster than the speed of those connections. This is where Cerebras Systems enters the frame. They didn't just build a better chip, they built a chip the size of an entire silicon wafer. It's called the wafer-scale engine, and it changes the physics of the game. Imagine a city where everyone lives in the same giant building. No traffic, no highways, no commuting. That is the architecture of the Cerebras WSE3. All the memory and all the processing power are on a single piece of silicon. On a traditional NVIDIA cluster, memory is separate from the processor. The data has to go back and forth, which is like trying to sip a milkshake through a mile-long straw. Cerebras puts the memory right next to the logic. The result? GPT-5.3 Codex Spark can generate code faster than you can read it. We are talking about an entire software library being generated in the time it takes to blink. It is a paradigm shift for engineering. But speed isn't just about being fast. It's about what that speed enables. In the world of Codex Spark, the Spark refers to a specific architectural optimization designed for low-latency reasoning. Traditional models, like the retired GPT-4 series, were heavy. They were designed to be human-like, with personas and conversational fluff. Spark is different. It is a stripped-back, high-performance engine optimized for pure logic and syntax. Think of it like a luxury SUV versus a Formula One car. One is comfortable and talks to you. The other is built for one thing: raw, unadulterated speed. And for software engineering, speed is the only metric that matters. So, we have the hardware and we have the architecture. But there is a catch. To reach these speeds, engineers had to make some fascinating trade-offs. They had to sacrifice the human feel of the AI. Retired models were famous for their vibes. They could be witty, sarcastic, or empathetic. Spark is cold. It is a machine that outputs perfect code with zero personality. And that is exactly what makes it so dangerous for the competition. But how does this actually work under the hood? How do you manage the heat and the power of a chip that consumes as much energy as a small house? That is where the engineering gets truly wild. To understand the Cerebras advantage, you have to understand the memory wall. In a standard computer, the processor is much faster than the memory. The processor spends most of its time just waiting for data to arrive. Cerebras solves this by using SRAM, static random access memory, integrated directly onto the wafer. It has 7,000 times more memory bandwidth than a typical NVIDIA H100. It's the difference between a garden hose and a waterfall. This massive bandwidth is what allows for 1,000 tokens per second. The model doesn't have to wait for the weights to load from external memory. They are already there, sitting right on the silicon where the math happens. But it's not just about hardware. The Spark architecture uses a technique called speculative decoding. Essentially, the model guesses the next few tokens in parallel and then verifies them instantly. Imagine a chess grandmaster who can see 5 moves ahead. They don't just think about the next move. They've already calculated the entire sequence. Spark does this for every single word it generates. This combination of wafer-scale hardware and speculative software creates a feedback loop. The faster the hardware, the more guesses the software can verify. It is a virtuous cycle of pure performance. However, there is a technical cost to this speed. Low latency AI is incredibly difficult to scale. When you have everything on one chip, you are limited by the physical size of that chip. You can't just add more as easily as you can with NVIDIA. This creates a fascinating divide in the industry. NVIDIA is building the infrastructure for godlike models that take months to train. Cerebras is building the infrastructure for instant models that respond in milliseconds. The question is, which one wins? Do we want an AI that is incredibly smart but takes 5 seconds to think, or an AI that is slightly less sophisticated but answers before you finish your sentence? Skeptics argue that the Spark approach leads to more hallucinations. When an AI moves this fast, it doesn't have time for the deep, multi-step reasoning that slower models use to self-correct. But the data suggests otherwise. For specific tasks like Python or Rust generation, the Spark architecture actually maintains high accuracy. It turns out that for logic, speed and precision aren't mutually exclusive. The engineering challenge now is KV cache management. As the model generates tokens, it has to remember everything it just said. At 1,000 tokens per second, that memory grows at a terrifying rate.
We are witnessing the birth of a new tier of computing. It's not just cloud or edge, it's instant-class AI. And it's about to change how every piece of software on your computer is written. Imagine an IDE that doesn't just suggest the next line of code, but builds the entire feature while you are still typing the comment. That is the promise of Codex Spark. But the reality is even more complex. To see the real-world impact, we need to look at how this changes the flow state of engineering. Because once the lag is gone, the human becomes the bottleneck.
In the old world of software engineering, you wrote code, you ran it, you waited for it to fail, and you fixed it. This edit, compile, run cycle could take minutes or even hours. Spark reduces it to milliseconds. This creates a live coding environment where the software is alive. You aren't building a static object, you are sculpting a living system that responds to your thoughts in real time. The psychological impact is massive. When the tool is as fast as the thought, you enter a state of hyperflow. You can iterate 100 times in the time it used to take to do it once. But this speed requires a massive investment in infrastructure. A single Cerebras CS3 system costs millions of dollars. For most companies, this level of performance is currently out of reach. This is why we are seeing a shift toward AI utilities. Just like you pay for electricity or water, companies will pay for token streams. You don't own the hardware, you just tap into the speed. NVIDIA isn't sitting still, of course. They are working on their own low-latency interconnects like NVLink 5.0. The arms race between massive throughput and instant latency is the most important battle in tech right now. Beyond coding, 1,000 tokens per second enables real-time reasoning for agents. An AI agent can now think through a complex problem, simulate 10 different solutions, and pick the best one before you've even finished describing the problem. This is the Spark philosophy, that intelligence is a function of iteration. If you can think 100 times faster, you don't need to be 100 times smarter. You just need to try more things. It's a brute force approach to genius. And with the hardware finally catching up to the software, we are about to see what happens when the brute force becomes instantaneous. Here is what I think this really means. We are moving away from chatting with AI and toward operating with AI. The era of the chatbot is ending. The era of the AI-powered engine is beginning. We don't need the AI to be our friend. We don't need it to have a personality. We need it to be a perfect, high-speed processor for human intent. And GPT-5.3 Codex Spark is the first true version of that. The engineering challenges are still immense. Power, heat, and memory bandwidth will continue to be the bottlenecks. But the path is clear. The future belongs to the fast. As we push toward 2,000 or even 5,000 tokens per second, the line between human and machine will blur in a way we never expected. Not because the AI is becoming more human, but because it's becoming more like a part of our own biology. The real question isn't whether AI will replace us. It's how much more we can achieve when our tools finally move at the speed of our dreams. This is the spark, and the fire is just starting. The world of 1,000 tokens per second is here. The only thing left to decide is what you're going to build with it.